Hello, crypto friends. It's Big Wise. Today I've got something a little bit different for you. I'm going to try and explain gas fees on the Ethereum blockchain. So, when you submit a transaction, you're probably familiar with MetaMask if you use MetaMask, showing you how much the transaction is roughly going to cost. So, what factors go into determining how much you pay? And why is it that sometimes for the same action, let's say you're buying one NFT off OpenSea, why is it that sometimes it might cost a few dollars, but at other times it could cost tens or $10, $20, or even more? So we'll get straight into it, and I'm going to be using my tablet that I bought recently because I want to be able to show you or draw some examples. And I have to say that I'm absolutely terrible with this. It's actually quite a cheap tablet, and it doesn't have the screen on the tablet itself. So I have to look at the monitor and try my best. So fair warning, it's going to be really bad. So I want you guys to think about a transaction like a car, right? Like a car, a motor vehicle. So if you think about, oh, that was no good. Hang on. Let me try again. So if you think about going from point A, beautiful, look at that, to point B, oh, professional. Okay, so in a car, to get from point A to point B, B is your destination. Once you reach point B, you're done. Your transaction is finished. But, pardon me, to fuel your car, to get from A to B, your car needs, funnily enough, gas. So where I'm from, we call it petrol. I think in America it's called gas. Some people might call it fuel. So it requires an amount of gas units. So in a car, it might be gallons or liters, right? To complete that journey from A to B. And the gas that's used depends on the distance you're traveling, if we're looking at this example. So from A to B, if it's a short distance, then you would only need a small amount of gas. But if it's a long distance, and let me try and do that, how consistent is my sizing here? A to B. If it's a longer distance, then of course you need more gas. Otherwise, your car's not going to make it. It's going to stop halfway. So this is one of the deciding factors that go into determining how much a transaction costs. So going in your car to your local shop is going to be very low gas requirement, and the trip from your suburb or your city to the next city is going to require a lot more. So how does that relate to, or how do you view that in terms of an Ethereum transaction? So I've got here an example of a transaction where just some ether has been sent from one account to another. So this is the simplest of transactions that you can have. In other words, it's like the shortest of trips from A to B. And on Etherscan, if you expand the click to see more, you're given a few other bits of data. One of them is gas limit and usage by transaction. So the limit is how much gas units you are willing to spend on this transaction, and the usage is the actual amount used. So going back to this example, in the short trip, maybe it takes 5 gallons of gas, but you might want to overcompensate and fill your car up with 6, because putting in like the exact amount, sometimes it's not enough and it might get rejected, or in the case of going from A to B, you might stop before you reach a destination. So MetaMask quite typically overestimates how much gas is required for the trip. So think of like the MetaMask estimation is like your navigation system in the car. So before you head off on your trip, you put in the destination and it tells you it's going to be roughly this amount, maybe 100 miles, 100 kilometers, whatever it might be. But just because the car says it's going to take this much distance, you're not going to put in gas or petrol just to cover that exact amount, because that's too dangerous, right? So this is where MetaMask will overestimate. And in this specific example, because it's sending Ether from one account to another, it's such a simple transaction that the minimum required, or the minimum that you can spend or you must spend, is enough to cover this. So that's why here you see the limit is 21,000 and used is 21,000, because it's a well-known function, like a consistent thing to do. But if we look at a different transaction like this one, where I've gone and swept some of my favorite NFTs, the On-Chain Birds project, you can see, if we expand here, that the gas limit set on this transaction is 1.25 million and the actual used is 1.07 million. So it's overestimated by 14.77%, and it's only used this much. So when you use less than what was set, like what you've overcompensated for, you don't lose out. So the difference between these two, you get back. So it's like if you're in a car and you know that A to B is going to take probably 5 gallons of gas, but you put in 7, then at the end of the trip, if there's 2 left, you don't lose that 2. It's still in your car. It's still yours. So the only reason that MetaMask overestimates, and it's a good thing for you, is so that there's a better chance that your transaction does process. There's a better chance that you will get to your destination without stopping short. So now that we know the gas, the one part is how much gas is required to get from A to B to do your transaction. So the second part is the price of the gas. So the price you need to pay for your petrol or your gas per liter per gallon. So those two things combined make up the final price. So I'll show you how to calculate, or how you can see it in this information, amongst this information. So we've got this much gas units have been used. So we'll just copy that and pop it into a calculator. So we've spent this much gas, and the price of gas is, as you can see, given here. So this is Gwei, which is 1 Gwei is 1/1000th of an ether. So this translated to ether is 0.0000, as you can see here. And the reason why Gwei is used, especially when you look at like the top of the Etherscan website, it tells you the current gas price. It's much easier to represent in a number like this as opposed to saying 0.000 and such. So that's all it is. But if we grab this number, so that's the price of the gas multiplied by the amount of gas that we used, we will come to the final cost, which is going to be, okay, so I didn't multiply that. So let me try again. That times, and this number. So I'll just type it in manually. 1070876. Okay, so you can see the total cost for the fuel is 0.004644 such and such, which you can see here, transaction fee. It matches up. And it'll be the same for this, whatever transaction you look at. So now we've worked out that to get from A to B, the gas required to complete the transaction, to complete the trip, is dependent on how far you need to go. So the longer the distance, the more difficult the trip. So the more complex the workload. So if we're just sending ether to someone, it's very simple, so it's a short trip. If we're doing something more complex, like in my example where I've gone and swept 7 or 8 NFTs, it's a much longer trip, therefore costs more gas. Now, when gas price is extreme, that's when the transaction costs in total can become out of hand. And the reason why that happens is because if you imagine, we're going back to the cars example. So if you imagine that you're there and you need to fill up your tank before you go on this journey, before you go on this trip, before you go and complete this transaction. But there's a gas station with maybe only 10 pumps. And there's like 5,000 or 50,000 cars wanting to use those pumps. And every single person is wanting to get to their destination ASAP. So, for example, let me draw here again. Oh no. So let's say, and I'm going to give you an example with the other side, the other deed minting day, where gas prices went up to 4,000, 5,000, 6,000. So suppose that the trip here is the same distance, and in this case, the price of gas is 6. Oh, this is difficult. That's meant to be a G. Is that a G? Yeah, that's good enough. 6 Gwei. But the price on this occasion is so much more because so many more people are wanting to get to the destination. So here is the grand prize, right? If you come here, then you get, I'm going to try and draw an other side land deed. I don't have one, by the way. And like, there's like mountains or like some kind of terrain. And if you're lucky, you get a little coda dude. Look at that. Is that what he looks like? There you go. Right? So the grand prize is waiting at B. And there's only 10,000 of these, I believe. Is that right? Something like that. So everyone is desperate to get to B. Fill up their tank and get to B. But there are only 10 pumps. So now everyone starts bidding to use the gas. They're like, okay, I'm willing to pay 10 Gwei per gas unit. Someone else is saying, I'm willing to pay 12. I'm willing to pay 200. And very quickly it gets out of control. So I'll show you the actual transaction for an other side, other deed mint. And this is from May the 1st. And you can see here that the gas price, 5,200 Gwei. But the actual gas usage is only 347,000. I say only because compare it to this sweeping transaction here. This took 1.07 million. So this trip is less than half. So let me see here. Where's my little... I've lost my pointer. Where's it gone? Oh, there it is. No, okay. So, where am I? Oh, there I am. So this trip actually is like maybe to here. And I'll scrap that out. Right? So even though the complexity of the trip, the workload for your car is nowhere near as high as my other example, the actual cost, which you can see here, it's displaying the current based on current Ether price. But if I click it, on the day of the transaction, it costs $5,100 because 347,092 units used times 0.000052 1.8. See the number? This one and this one. So that's the problem that you run into when you have popular mints and people outbidding each other, prepared to pay ridiculous amounts of gas to travel a short distance, all because there's, like I said, like a pot of gold, or so they think, at the other side of the there you go, other side of the trip. Now, when you use MetaMask, it generally estimates or gives you recommended settings in order for your transaction to go through or give it a decent chance of getting through. MetaMask will say, we recommend this and these settings, and you just click submit. And most people don't really think about or care about what goes on behind the scenes. But behind the scenes, like, all this stuff is happening here, and now you know how the final price is determined. I've got one other point that I want to make about these costs, transaction costs, and that is, I've lost my pointer. Okay, here it is. I'm running out of room on the tablet. I'm not sure if I can go any lower. So whilst we looked at transactions or trips A to B in a straight line, if the contract is not optimized, then it's like a trip that goes like this. Maybe might do this. We'll go here. And then eventually arrive at B. So a non-optimized contract will cost more than it really should, because the coding isn't ideal. So, for example, maybe it's doing some unnecessary calculations. Like, let's say, instead of it wants to calculate 10 to the power of 10, but instead of using a mathematical function that does the actual power of, instead of that, you're doing 10 times 10 times 10 times 10 times 10, etc. So that's like being inefficient. So the more inefficient parts to your code, the longer the trip is going to take. So when you hear devs or projects, they might release an update and say maybe their first minting session was quite expensive and people were complaining. They might come out and say, we've just optimized our contract, so try again, it should be cheaper. So what they mean there is that they've gone and tweaked, reviewed their smart contract code to make sure that instead of having these squiggly lines taking the long route to get from A to B, they're trying to make it like a straight line, or as much as possible. So that's sort of the optimization when you hear optimization of code that leads to gas savings. So that's about it. That's like a very simple, basic introduction. There is a little bit more that can be going on behind the scenes, and there are things like you can manually adjust the settings in your MetaMask so that every transaction you might want to pay less gas, little tweaks you can do. But for now, I think this is probably a good introduction. Not only did you get to hopefully understand gas a bit better, but you also got to see my fantastic drawing skills. So yeah, so that's it. Hopefully next time my tablet skills have improved. Thank you.